Hey there, ladies and gentlemen, boys and girls. In this video, we're going to be learning how to multiply radical expressions. As an intro, we're going to avoid throwing variables in there just so we get kind of the mindset of how this behaves strictly with numbers. And then as we go forward, we might throw a few variables into the mix. So with multiplying radicals, a few things to take note. Numbers underneath a radical are only allowed to multiply or divide with other numbers underneath a radical. Numbers outside of radical can only multiply or divide with other numbers outside of radical. When we go through and do this multiplication, we're going to see if we can simplify things first. If we can, great. If not, we'll go straight into multiplication. So if I look at this first one here, I've got rad 3 times rad 5. Rad 3, if I tried factoring that out, would just be 1 and 3. And since 3 is prime, I can't really break that down. Same thing goes for 5. So they're both under a radical. If I multiply them together, 3 times 5 is just 15, so I'm stuck with rad 15. Then if I tried to simplify this, because we always want to simplify at the very end, I could factor that into 3 and 5. Those are both prime. I don't see any pairs, so I can't reduce or simplify it. Rad 15 would be my final answer. If we move over here, we have 2 rad 6 times 4 rad 3. Same thing. First, I'm going to check to see if I can break down either of my two radicals. 6 breaks down into 2 and 3, no pairs, and then 3 we've already discussed. So what I'm going to do is I'm going to multiply my outside numbers. These are kind of like coefficients. So 2 times 4 would give me 8. And then I'll multiply my radical terms together. I've got rad 6 and rad 3, and that gives me rad 18. Now from here, I'm going to see if I can factor and reduce this 18. Well, if I were to make my prime factorization or use the perfect squares method, however you choose to do this, rad 18 is going to eventually break up into a 3 rad 2, meaning we'd have a pair of 3's and we'd have a 2. The 8 kind of comes along for the ride, so we have 8 times 3 rad 2, and that's going to give me 24 rad 2. Let's go on to some more complex type problems. Here we have rad 20 times rad 48. If I were to multiply these straight away, 20 times 48, that's going to be a pretty gargantuan number, and I don't really feel like doing a prime factorization on that. So what I'm going to do first is see if maybe we can factor this thing out and simplify it. So a lot of you are big fans of the prime factorization, so I'll do the prime factorization here for both. Two numbers that multiply to be 20 are 10 and 2, and then 10 breaks down into 5 and 2. I see a pair of 2's and a lonesome 5, so this becomes 2 rad 5. I'll do the same thing on the 48. 48 can break down into 4 and 12. 4 breaks down into 2 and 2, and I've got a pair of 2's right there. 12 can break down into 6 and 2. 6 can break down into 3 and 2. I've got another pair of 2's there, and a leftover 3. So rad 48 is going to turn into a 2 times 2 rad 3, so 4 rad 3, because I had two different pairs of 2's. So now when it comes time to multiply these together, I've got the 2 and the 4 on the outside. That's 8. On the inside of the radicals, I've got a 5 and a 3. That's 15. And we've already discussed from the first example, 15 cannot reduce, cannot break down. This would be our final answer. Last scenario you guys might see is a situation in which we have a radical expression hanging outside of a parenthesis term. Well, if I were to pretend this was, say, something like 2 times x plus 3y, we would have no trouble just doing some distribution on there. So if I distribute that in, I'd get 2x plus 6y. Same thing's going to hold true here. We're going to distribute the outside term onto both of the pieces inside. Well, first let me break down this rad 12. Rad 12 is going to break down into a 2 rad 3. We still had the 3 hanging out front. So really that's going to be a 6 rad 3. We're going to distribute that into the quantity 5 or 2 plus 5 rad 6. Now as we go through and do this, let me change the camera angle there. I have 6 rad 3 times 2. Well, 2 is a plain old number, not a number underneath a radical, so that's going to interact with the 6 and not affect the 3 at all. So that's going to become 12 rad 3. And then if I take 6 rad 3 and distribute that onto a 5 rad 6, the 6 and the 5 will multiply together, and that's going to give me a 30. The rad 3, the rad 6, those are going to multiply to be rad 18. Once I hit this point, I'm going to check just to see if I can simplify anything down a bit further. 3 will not reduce down at all. 18, however, if I were to factor this out, I'd get a pair of 3s and a single 2. So that turns into a 3 rad 2. We still had the 30 that was out front. So I've got 12 rad 3 plus 30 times 3 rad 2, also known as 12 rad 3 plus 90 rad 2. And that would be our final answer. As always, if something didn't make sense, please do not hesitate to come see me or send me an email and I'll clarify the best I can.